So, hi Gunnar, welcome back. And you were the last time in 2019. I thought,
Oh wow.
I thought
Yeah, hey
like
there.
last year, but it was 2019.
Yeah,
Um,
I wasn't sure. I was wondering the same actually. I wasn't sure when it was for the last time that we spoke, but yeah, 2 years then. Wow.
yeah, you were twice, I think, in 2019, and I thought, you came back in 2020 or 21, but it's not true.
I was waiting for your call every week and you didn't reach out and I was so sad.
This is not true because once I remember you asked me something about exceptions, and I said, okay, I have no time, but we can set up a podcast and talk about that. And you
Oh
answered
really?
me, yeah, and you answered this is not enough, to talk about. I was like, okay,
Oh yeah, yeah, right. That's true. I remember that. Okay,
you,
yes.
you see.
You're right. So I missed out essentially. Okay.
So
Fair enough.
Debezium. So what happened since last time? I used Debezium in lots of projects in various
Oh
ways.
really?
Yeah,
Oh wow, that's awesome.
yeah, and
Okay.
if you're interested, I just tell you some use cases because they are I don't know whether they are usual or not. So the typical use case, of course, is just data migration between databases, but this was not the main use case in my world. So
Okay.
in one project was we had already high performance system, and they wanted like a low risk opportunity to have microservices with additional analytics logic. So,
Mm-hmm.
of course, what happened was we externalized the database using Debezium in a couple of topics, and
Mm-hmm.
then used Quarkus to how to call it, to make the topics more business-like. So usually topics are very technical. If you get the data
Right.
from Debezium, you see everything. So the first task was to convert them to more business events. And then for me it was almost done because then you could just use Kafka and use analytics and do whatever you like. So this was the one main case.
Okay.
And in other
So
projects,
what did you use on the analytics side for it?
first, if you start with Kafka, my clients are already happy because the windowing functions are, for instance, great. So what they did
Okay.
before,
Oh, okay. I see.
they had to poll the database, but with Kafka it just works with Kafka streams. So I have
Yeah.
to tell, if I use Kafka, I always use Kafka streams because
Oh,
I, I
okay.
I don't see the point to use Kafka and play with byte arrays or just with objects. This is like GMS. So if I use Kafka, it should be additional added
Yeah.
value, and KSQLDB, which is a kind of creating
Right.
Kafka streams in ASCII, I would
More
say.
declarative. Yeah. Right. Yeah.
Yeah.
Okay. Cool. I see.
So and then of course stock Java logic, because either we used microprofile reactive messaging, where
Mm-hmm.
we just got the POJOs and then you could do something with them. This is not exact streaming, but almost, or the declarative way with Kafka Stream. So this was the analytics part,
Mm-hmm. Okay.
and sometimes Presto DB.
Right. Okay. I see. Yeah, I see that coming up more often lately. I was talking to the Trino DB guys, right? So there was a sort
Yeah,
of a
exactly.
project
Trino.
split, and I was talking to the Trino guys. So yes, definitely, there's lots of interesting opportunities in using these projects together for sure.
Yeah, and the other project is actually cloud migrations, because
Okay.
what often happens is that my clients would like or have to go to the clouds, and but I don't know whether this is also your perception. My perception is that the clouds are widely misunderstood. So what really, because it happened the last 2 years, I would say in 90% of all cases, and the perception is like what we're doing on premise is way too complicated, and
Mm-hmm.
cloud are easier and very, you don't have to program a lot. You just can go to the cloud, do something. So this is the one perception. And
Right.
the other perception is, if you take your local Kubernetes cluster from premise and put it to the cloud, it's going to be cheaper. So they are
Okay.
too, and this is of course terrible idea. And what we do if we go to the cloud, for me, there should be a difference. A measurable business advantage. And
Right. Right. Definitely.
yeah, and then what you can do, of course, do serverless. And what serverless means is, in the clouds, that the management, see at the end of the month how expensive the cloud actually is, and
Mm-hmm.
management also sees how expensive is a single transaction. So this is the main idea. So they see the direct
Right.
link between what happens from the business point of view and how much does it cost. And so if you do it this way, so serverless, then of course the architectural pattern which only works is event-driven architectures.
Okay, yeah, I see.
Because this is really true because in all clouds, all the serverless stuff is actually event-driven. So this mostly the most famous example is HTTP. Is like API gateway where you can run Quarkus as a JAX-RS resource, but this is like synchronous invocation, and this is the least interesting serverless solution, I would say. The more common way is where you have something like message-driven beans. These are Lambdas or Quarkus or Funky or whatever, and they are waking up on event. So you can use now Debezium on premise to pump data to local topics. And then it's interesting because if the data is persistent in Kafka, you can register to the topics and migrate them to the cloud. And in the cloud,
yeah, definitely.
Yeah. And in the cloud, you don't have to use Kafka anymore. You can use Kinesis or whatever because it depends on the costs. But you have, the synchronization is solved. And all the events are already in the cloud. And this is not like, your second Kubernetes cluster is more like now we have a clear advantage. So this is where I spent, my time in the last 2 years with Debezium to give you a kind of feedback. And in one project, maybe we will, this is the first time we will maybe synchronize between DB2 and Postgres or replicate. But this is not boring use cases, right? Everyone tries to,
Okay, I see. I mean, that's definitely interesting. So, yeah, cloud migration for sure, or let's say on-prem to cloud migration, there's definitely a use case which comes up a lot in the Debezium community. And as you say, you are using Kafka, let's say on-prem, and then you go to Kinesis on AWS. There's this thing, in case you have not seen it yet, which is called Debezium Server. And it's another way of running Debezium. So essentially you have 3 ways how you can use Debezium. One is the one which I believe you do via Kafka Connect. So you deploy it into Kafka Connect as Kafka Connect connectors, right? So that's the first one. I would say the most common one. So I always say 90% of our users are doing that. But then what you also can do is you can use Debezium as an embedded library in your Java application. It could be a Quarkus application, Spring Boot, or what have you. And then you just would register a callback method, which should be invoked for each change event. And then you can react to the changes right within your JVM-based application without Kafka involved at all, if that's what you want. And lastly, there's thing Debezium Server, and this essentially takes this embedded engine, but then makes it available as a ready-to-run process. So again, it's based on Quarkus, and then you can use Debezium Server together with multiple sync connectors. And actually, we do have one for Kinesis. We do have one for Google Cloud PubSub and all those kinds of things. And now this means you can use this Debezium Server thingy, and you can go straight to Kinesis if that's what you want to. So you wouldn't even have to go through a Kafka topic.
I mean, Kafka is great, but in the clouds, its costs are everything. I would say, in the cloud is like what I refer to as cost-driven architecture. Whatever we knew, 5 years ago doesn't matter. It has to be cheap, and
definitely.
All nasty hacks.
And I mean, it's right, and it's a question of where you want to consume this data and how you want to consume it, right? So let's say you are big on AWS. And you are big on Kinesis already for integrating your different things, but then it might make sense to use Debezium Server because, well, this is the easiest way to get your data change events into Kinesis. Maybe if you are a Kafka shop and you just have this one Kinesis use case on the side, so maybe then it makes sense to use both of them. But really the idea we had is to give you some options, right? So we want to do CDC and that's what we want to solve for our users. And then they can consume Debezium and the change events in whatever way they want, whatever makes the most sense for them. That's the idea.
So this sounds actually interesting. So what you are telling me right now is that you have also embedded connector, and the embedded connector could be embedded in a server, and we just call it Debezium Server. So
yes, right, exactly. But that's already happening, right? So you can download that and you can use it. And we have and it was interesting to see because so once we created Debezium Server, all those people who work with the different messaging infrastructures like Apache Pulsar or Redis Streams or Google Cloud PubSub, all those kinds of things, we got tons of PRs for adding support for Debezium Server for that because, well, people are aware of Debezium and they would like to use, that open source change data capture, but maybe they are not on Kafka necessarily, right? And so that's why Debezium Server is very interesting for these people because they can use Debezium and it works natively, let's say, with their sort of messaging infrastructure.
Yeah, the Kafka connector is like a process which hooks from one side to Kafka.
Right.
And to the database, and uses a mix of JDBC hacks, I would say, and low-level libraries. So it really depends. So what I observed is, if you do the snapshot thing, what it does is it hooks to the event system, but it uses JDBC to fetch all the data. So this is what my observation, what happens under the hood.
Exactly. Right.
Yeah. But the embedded connector and the server is the same functionality, but
it's the same thing, really. It's exactly the same thing. It's just the runtime of the connector that's different, right? So really, the Debezium Server, it has the same role to play in an architecture like Kafka Connect, just that it lets you connect to different messaging infrastructures. That's the key difference. And for the embedded engine, I would, many people use this who have some sort of advanced integration-like use case. So let's say Apache Flink, they would like to use Debezium change events, and they would like to have a Flink connector. So they have built something based on the embedded engine, which then directly feeds those change events into Apache Flink.
Yeah. There is actually one advantage, because the connector usually runs close to the database, and the problem is we always try to keep the configuration basic, because if you have to fiddle with the configuration, usually there are different roles involved with management of the connector. But if the connector could run outside, we could do more. Like, for instance, I would put more, conversion logic or adapter logic to convert, the database types to more advanced Java types. As you could do more. But one thing is, if the connector runs as a Kafka connector, Kafka watches and restarts the connector, and also I think provides additional persistence for the index, right? But if you run outside, you do the same, right? Because you use yeah.
Right. That's a good question. So yes, in terms of the restarting, so actually, there's some subtleties around that model in Kafka Connect, and I believe it reminds me of the model which we had with the application servers, right? So you have this long-running process, you deploy multiple applications, or in this case, connectors into this runtime, and then you have lots of challenges actually around it, right? So let's say one of the connectors eats up all the CPU, or one of the connectors produces an out-of-memory error. Well, then all the other connectors are impacted by that as well. Or you just want to look at the logs of a single connector. Actually, it's not very easy with Kafka Connect, because usually you will just see all the logs of this process, which may run multiple connectors. So that's why I typically recommend people to not deploy multiple connectors into one connect worker or cluster even, but rather have a connect node, or even a connect cluster if you want, per connector, because it just gives you better isolation properties. Yeah. And I'm saying that because this restarting notion, all that, I would probably see that rather at an orchestrator level. So there's some ideas which I was thinking about. So maybe you could have another model of Kafka Connect, where you move more of this orchestration logic to something like Kubernetes, actually, or an operator, and then this one would be in charge of spinning up multiple processes for different connector tasks and so on, and you would get away from this application server model which you currently have in Connect.
Yeah, this is true, because sometimes if the container is restarted, I wouldn't. I was surprised, to go to Kafka and watch the logs. This is for me. What you're referring to for me is more like a microservice idea, right? So, the connector runs in a process outside, exactly. So, what you did with the, I would say the embedded connector and the Debezium Server.
Embedded engine and Debezium Server.
Embedded engine and Debezium Server are actually implementation of the idea that the process is running outside of Kafka and still remotely connects to Kafka, so it still uses the same indices, that it remembers where it left off, so you don't lose any consistency, but it's just the runtime is a different runtime, right?
Exactly right. Exactly. And as you speak about the offsets, so that's actually also a pluggable matter. So you can plug in different offset stores. So let's say the default that's then you would store the offsets in Kafka topics, right? So which makes sense if you are using Kafka. But then if you are using Kinesis or whatever, you probably would not just go to Kafka to store your offsets, right? So that's why this is pluggable, and there's a JDBC based implementation, for instance, work in progress and alternative means, and you just can do your own one. So, you can store everything in a single place.
Okay, and if I'm running in the embedded mode and I'm plugging into, so the configurable side is always the configurable side are still databases, and the other side is Kafka or another streaming system. This is what you're working on, right?
Exactly. So you would so that's the case for the Debezium server, right? So there you would essentially configure a source connector, a Debezium source connector, and then you would configure that sync. This we call it the outbound adapter, which describes this messaging infrastructure. Mm-hmm. You would configure those two things with Debezium or with the embedded engine. Essentially, you just configure the source connector, the Debezium connector, and you tell Debezium, okay, that's the method, my Java method, which I would like to have invoked whenever there's a change event. So it's like a method reference, which you pass to it. And then this will be invoked, and whatever you do there with the change event, that's up to you, right? So you can print it out to the console, you can, store it in a file, whatever you would like to do. And then Debezium will still take care of the offset management, and it will persist the offsets in a offset store which you have configured.
Yeah. So the inbound are still databases like MySQL, right. Postgres, Oracle, and DB2, I think. And the outbound is usually a streaming system, right?
Exactly right.
But it could be also a REST endpoint?
It could be. It's interesting you say that because, so yes, exactly. So the original idea was that the outbound connectors would always describe a messaging infrastructure. And I believe that makes lots of sense because it gives you this optionality, right? So you can reread topics, you can have multiple consumers. So you don't have to think about the consuming side when you produce the change events. I believe that's a big advantage. But then actually, just recently, somebody built a sync connector or outbound adapter for the Debezium server, which sends events to Apache Iceberg. So, which is this file format for analytics, and you can, describe your files, let's say on S3. And in that case, well, that's not a messaging infrastructure, but really it's a sync system, like something like S3. And they found this useful because, well, they have the direct pipeline from their database to S3 in this case. And maybe they are not interested in this sort of optionality, so it makes sense for them.
Because I got an interesting use case, maybe. If you probably know, you can run Quarkus as an AWS Lambda behind an API gateway. And you need the API gateway because the API gateway translates the HTTP calls to HTTP events. And the Quarkus picks the HTTP events and translates them to JAX-RS calls. Mm-hmm. But with your Debezium server, we could skip actually the API gateway.
Yes, definitely. I mean, so yeah, you could. I don't know. How would you consume the events then via Lambda invocations?
It doesn't matter because you could map the Lambda to different resources, and the HTTP event is just a JSON format. So there would be some experimentation because I'm pretty sure if you would tell Quarkus, listen to this Lambda. The Lambda can be invoked by different sources. So what we would need is to experiment whether it could also pick the events from SQS, for instance, or SNS. It doesn't matter. And if this event delivers an HTTP event, let's say, then this JAX-RS could pick that. Right. But in this particular case, because you are also in charge of Quarkus indirectly, we wouldn't even need the entire HTTP event. We could just write whatever we like, just to invoke the post methods in JAX-RS. So this was just as you described that. I say, okay, this could be interesting because the idea that you have locally something running and consuming database events and pushing them to the cloud. So push could be directly communicating with SQS SNS, or it could also be you are invoking post or put methods. And this is where the idea was. Is it hard actually to implement such an adapter? So which receives the event or?
Yeah, no, I don't think. I mean, it's essentially a bit of glue code, right? So essentially you just need, you have this callback method. You need to make sure to invoke whatever endpoint it is you need to invoke. Then there's some subtleties around batching if this is supported, for instance. But it's not too difficult. No, it's, I don't know, a few days, I guess it would take you with testing and everything.
Okay, so it sounds interesting. So the first step would be, of course, just, like a zero connector, just receive everything and log it.
Right.
This would be,
Yeah, and we are very open also for contributions there. So as I mentioned, we have quite a few of those outbound connectors at this point, and we can add more. They don't create lots of effort in terms of maintenance for us, so that's why I'm pretty happy to add more as people want to contribute them.
Okay. This is what happens on the Debezium front. So which database is already supported right now? You remember them?
Right. Oh, yeah. So let me see. So we have MySQL and Postgres, which I believe are the two most commonly used ones. We have MongoDB, which is very interesting. So right now we are working on the Debezium 1.8 release, which will be published at the end of the year. Mm-hmm. And the MongoDB connector, it's a part of a key area for that release. So we, for instance, we will support now what's called change streams in MongoDB. So that's a new way of getting change events out of MongoDB, which, for instance, let us get change events also from MongoDB 5. We will have support for the Outbox pattern with MongoDB. And there's also this notion of incremental snapshots, which we just recently added. We can speak about that a bit in more depth, maybe. So that's also supported for MongoDB now. So, lots of things coming from MongoDB in this release. But then also we have DB2, as you said. We have, let me see. Cassandra, that's a community-led connector. We have Vitess, which also is a community-led connector under the Debezium umbrella. And there is more, I don't remember it from the top of my head. Of course, Oracle, we also have Oracle. So altogether, we have 8 connectors under
Microsoft SQL Server?
Oh, yeah, of course. Definitely. Exactly. That's the one. Thank you. So SQL Server, that's also there. And that's also interesting to see. So this model of governance, let's say, that's also evolving. So we have those connectors, which have always been worked on by the Debezium core team, and it was mostly Red Hat engineers who drove the work there. Now we have, in addition to that, we have this notion of what we call community-led connectors, where it's folk from other companies, so it's not Red Hat engineers, but others who drive the work on that connector. So that's the case for Cassandra and Vitess. That's separate repos under the Debezium organization on GitHub, but it's other folks who drive the work there. And then there's a third level, which is, growing right now, which is also very interesting. And there's this external people work on their own connector, which is based on the Debezium framework, but they don't do it as part of the Debezium organization on GitHub. And this was the case for ScyllaDB, which is this NoSQL store, which is API compatible with Cassandra and I believe DynamoDB and a few others. So when the Scylla folks were looking for, a CDC story for getting the changes out of ScyllaDB into Kafka, they came across the Debezium connector framework and they said, okay, so we will take this framework and we will then implement this connector on our own GitHub organization, and we are the maintainers of that. But still they have the format compatibility with the Debezium change events. So this means now if you are a user, you can use the Debezium core connectors or you can use the ScyllaDB connector, and it will give you the same change event format. It will give you the same sort of configuration experience. And it's very interesting to see how Debezium, grows and grows, and it also becomes a de facto standard, I would say, for change state capture.
Okay, so what exciting features you see in Debezium recently were implemented? So you already mentioned some. So there are databases, various databases. So what are the nice features you like the most? Mm-hmm.
So let's say, I would say one part of that is really the idea to make Debezium an entire platform for change data capture. So really not only being, Kafka Connect source connectors, but be a true CDC platform. And there's a few efforts which attribute to that. One of them is, for instance, this Debezium UI. So we are working on a graphical user interface. It's a web-based UI, which lets you configure Debezium connectors, which lets you examine their state, restart them, and so on. So that's pretty exciting.
Are you using Angular?
No, we are not using Angular.
Very
but
good.
Using
okay.
React. But I mean, I'm not that much involved with UI because I'm not a big UI expert. So there's separate engineers working on the UI. But of course, it's happening in close collaboration. So I do know it's based on React, but that's pretty much all I know.
This is an Angular anecdote. As you probably know, I did some workshops at the airport Munich, and I did also Angular workshops, and I do it like 5 years ago. And once we started like with one button, and someone and just everything broke and nothing worked. And then turned out that an attendee just watched the folder, and Angular downloaded 35,000 JavaScript files.
Oh my goodness.
For this button, and and then what happened is the one attendee asked me, okay, Angular comes with like a code generator for the JavaScript stuff. So could we just upgrade, use the recent features? Of course. So I did it.
Okay.
And then nothing worked because the Angular version was different to the generator version, and we spent three hours debugging the Angular framework.
Yeah.
And so what happened then is I deprecated the courses, and I say I actually don't believe Angular. I got so many requests regarding Angular, so I'm doing this, but this is the only course where I do something, without believing in it, and I just canceled the entire course. It was like 5 years ago. So this is like, and you said, okay, building the UI. I immediately thought, about my Angular.
Oh, I see. Yeah. Yeah, I mean, UIs are so complex, right? It's and also there's so many frameworks popping up and new versions, so it's hard.
But React is not nice. React is actually reasonable. So it's
I guess so. Yeah. That's what I keep hearing. It seems to be pretty good. Yeah.
Interesting. So you being UI, what you can do with the UI? The use cases.
Yeah, so, well, the idea really is, to make it easier for people to set up connectors and to run Debezium. So, because that's one of the feedbacks we got, there's lots of configuration options. It can sometimes be hard to understand their implications, and, people maybe sometimes have a harder time to get started with Debezium than we would like them to have. So that's the idea, to help them there. And to give you one specific example, so there is this idea of filters, right? So you can specify which are the tables or which are the schemas I would like to capture. And you express those filters in terms of regular expressions. So this works very well. It lets you very fine-grained specify the set of tables you would like to capture. But then it also is prone to subtle details, right? So let's say you're not familiar with the regex syntax, or you just get it wrong, and you may end up with capturing not any table whatsoever. So that happens quite frequently. Then people are wondering, I don't get any change events. Why is that happening? Well, you have excluded all the tables. So that's and that's some of the things we would like to avoid, right? We would like to help people to not run into this sort of issue. And that's why the UI, for instance, allows you to preview the outcome of those filter expressions. So you specify your filters, and then it will tell you, okay, those are the tables you would be capturing with those tables. And then you can work on the filters and modify them until you see, okay, that's the set of tables I'm interested in. And it's a few other things like that. So, you have drop downs for, let's say, enumerated values. You have the help description in the UI. So it tells you what's the purpose of those options. It's grouping the options so you get an understanding of what's important and what's maybe more optional. And really all those things which help a user to get started with Debezium more easily. That's what we currently have. But then we also would like to add more, like really give you support also for running the connectors and, see where they are at, maybe do some sort of lag, analysis, if you are falling behind the source, transactions and this kind of stuff. So it's work in progress, and we are building out this, UI right now.
Okay. Interesting. Is it already working, or is it just?
Yeah. You can go to our documentation. There's a page, Debezium UI. It's a container image which you can download, and you can just download it and get started with it.
Okay.
Yeah. So that's the UI. And another big thing is this notion of incremental snapshotting. So to give you some background there. I guess. So if you start up a new connector, it optionally can take this initial snapshot of the data, right? As you mentioned, via JDBC, and then it will scan all the tables, will produce like a create event essentially. And then once the snapshot has been completed, it will go over to the stream reading mode, and it will continue to read the events from there. And in the past, we got lots of questions around it. One of them was always, how can we change our filter configuration? So let's say you have set up your filters and you are capturing, 10 tables. And now there's another table, which you also would like to capture and which doesn't match those filters which you had defined before. And there was no good way for doing that, for changing those filters, and then maybe do just a snapshot for this new additional table. You couldn't really do it in a good way. Sometimes people would like to just redo a snapshot of a table. Maybe they've lost the data in Kafka. Maybe the retention was too short, something like that. So they would like to rebootstrap just one or a few topics. Or they would like to pause a snapshot as a connector gets restarted. So this also was the case in the past. If a connector was doing the snapshot and you were restarting it before the snapshot was completed, you would have to redo the entire snapshot. And depending on the size of the tables, this can take a while. And all those things are addressed with this notion of incremental snapshotting. And this essentially allows you to trigger an ad hoc snapshot while the connector is running. So you can trigger it via different ways. For instance, there's what we call a signaling table. So you can insert like a command record into the signaling table, and the connector will pick it up from the table, and then it will do a snapshot for just a particular table or multiple tables. And then this runs essentially concurrently with the stream processing. So there's some sort of deduplication going on, and the semantics are a bit different because it might happen. For instance, you get an event, you get a snapshot event for the one record, but then you get a stream event, an update event for another record because, well, it was updated because the snapshot was running. So there's some subtle semantical differences, but then it's
different record types, because usually I think C is create, right? U is update, I guess.
Yeah.
This is like a third one now? Like
no, so the event types are the same.
Okay.
But what could happen is, so let's say before you would know for all my records, I will get this C record, or let's say this R record for read event from the snapshot. Mm-hmm. You would know for all my data, I would have this R record once the snapshot has been completed. Whereas now the guarantee you get is for all records, or for each record which there is, you will either get this R record, or you will get an update record if this happened to be updated. So it could be either or, and you don't really know what you will get. But in the end, once the incremental snapshot has completed, you will have all the data in Kafka, because also the update records, they give you all the data, right? Mm-hmm. So that's there's some differences around it. But really, it resolves all those issues, because now you can re-trigger snapshots at runtime. You can change your filters, and you can, then bootstrap this additional table. And this, I should say that's all based on a research paper which Netflix wrote. So Netflix engineers, they also work on an CDC system, and they mentioned they would open source it last year, but since then I haven't seen it, so it's not open source as far as I know. But what they did do is they wrote a research paper about this watermarking based snapshotting algorithm. Oh. And essentially we read this research paper, we found, okay, that's very useful, it's great work they do, we would like to have that in Debezium, and then we implemented it.
Hey, if they don't open source it, then we will create a documentary about that, why they didn't, right? So and publish it on Netflix,
That would be funny. I know we had a short conversation with them, but I haven't heard anything. It was early last year, and since then I haven't seen anything apart from that research paper. And I really appreciate that they wrote that and made it available. So it's a very nice improvement, and well, they did a great job with providing that information.
But for my understanding now, so let's say the first snapshot was successful. I have all my data then in the topics.
Right.
And I just restart the snapshot. What happens then? Will I get additional events, or is it smart enough to scan the topics, or what do you?
Yes, no. So the way it now works is it goes through the tables in a defined order. So essentially it does an order select by primary key. Mm-hmm. And then it will also store in the offsets, this is how far I got. Yeah. So let's say I got until primary key 10,000, then it will continue from 10,001, or let's say anything which is larger than 10,000 with the next chunk. So it's a chunk or a window-based process, essentially. Goes over the tables in chunks, and it will continue from there. And this also is stored in the offsets. So if you restart the connector, it will know from where to continue.
This is what happens now, and what happened?
No. That's yeah, exactly. But that's what's happening now. And before, well, it would just see in the offsets. Oh, I was in the middle of a snapshot. I will just restart from scratch. So even if I had read already 99% of the data from a table, it would just restart everything.
But then before we could get duplicates, right?
Yes, definitely. You would have duplicates in that case. I mean, that's something you need to always be aware of with Debezium. It always has at least once semantics. So there's failure scenarios, things like that, where you could get duplicates. So as a consumer, you always need to be ready for that. Yeah,
but before you your improvement right now, you would get actually duplicates for every business event, right? And now you get maybe, a view duplicates if something goes wrong. What can happen, I guess, if someone creates an event and you are snapshotting at the same time? This is more likely that you will get two events, right? I guess.
Now with the new approach?
Yeah.
Yes. So well, what happens is in that case, essentially, so it goes through the table, let's say in chunks of 10,000, and then within that window, it will deduplicate the data. So, let's say we receive an update for a particular record, and it also got selected in the snapshot record or in the snapshot select in that particular window. Then we would only propagate one of them, I believe, the update one.
No, I think the other way around, right? Because I guess you read with read committed. I think because you cannot just lock the table, so you read properly with read committed isolation level. So if I would write and you are in the window, you won't see my write.
Yes.
This is what I'm just thinking. What can happen?
So I mean, the deduplication should work fine within the window, but still, what always could happen is, of course, which makes sense, that we snapshot it in one window and then you do an update in the next one. Then you will see that update, which makes sense.
You will see the update, but I thought that you will get a duplicate, which is not true. What will happen is you won't see my change, but in the next update you will see the change. So maybe this update will happen through the streaming and not through snapshotting, right? This will happen exactly. So interesting. Yeah. Okay, so interesting to know. So what means right now? Okay, so what you did during scanning, you storing in a Kafka offset or in a state, summer state system.
In the Kafka, in the connect offset, right?
In the connect, of course. No, not of course, because pluggable right now, right? So you could actually replace it. So, but
exactly.
In 90% of cases, Kafka offset. So you are scanning the table, and during your scan, you are writing to Kafka offset what you actually scanned. And before that, it was you had to scan everything to be successful. There was no state, right? Associated.
Exactly right.
Okay. And why you needed the research paper from Netflix? Because it doesn't sound that hard, right?
No, that's true. I mean, but still, you need to have the right idea, right? And let's say, so before that, we always were very focused on that idea to do a consistent snapshot before we do the stream reading. We didn't really think about it that way. You could do a snapshot, and while that is happening, you also could already read events from the log. I believe that's the major difference. And that's what we learned from the paper. Yes, I guess we could have come to that by ourselves, but we learned about it in that paper. So
because if you are scanning, why I'm curious, if you are reading the tables, you are using JDBC, at least what I saw. So, and if using JDBC, they are the isolation level. So with that, you can tell how consistent the scan has to be. If it is too consistent, then it is slower. So the others won't be able to write or are going to be blocked. But this is what you can do. And the streaming part, let's say in Oracle, depends on the settings of the how it's called, Golden Gate. I wouldn't.
Log miner.
Log miner, right? Yeah. And in Postgres, I don't even know whether it's configurable because it's the logical decoding. I think is the name, right?
Yeah. Exactly. Yeah.
And so this is the actual transactions from the database, the other transactions. So we have actually two transactions in place, right? One is reading. This is your snapshotting, and the other one is the regular database transaction. They are competing inside a table. So this is the problem you have.
Well, in a way, but I mean, the stream reading happens from the transaction log, right? So at that point in time,
you're right.
Transactions have been committed, so we don't really compete with any transactions which are written to the database in that sense.
This is true. The streams are reading from the log. This is true. You have one. Maybe this is the where the research happened, because you are reading after. As this is like outside the database, you are reading from the archives, let's say, from backup, right? So you can see, or from replica. This is actually more common way.
Yes.
Because Postgres thinks it replicates to you, and this is actually Debezium. So you are reading from replica. The replica is used for the events, and you are reading from the master for snapshotting. This is what. Okay.
Exactly right.
Okay, now I'm happy. So now we covered the architecture now, how it works with. Okay, so this was the nice feature, because if the database is huge, and I already saw in my case, it was a subset of a database, but I think it took like 5 to 10 minutes until everything was replicated. So
yes, and then to be honest, I mean, people are running snapshots which take much longer. To be honest, so that's also something we would like to do. We would like to explore how we can parallelize the snapshot execution, right? So you could think about having multiple threads which run multiple snapshot transactions in parallel on different subsets, different chunks on the data, of course. So that's also something, maybe we get to that in 1.9 next year. So it's definitely a thing we would like to explore, because, well, it's the feedback we get from people. Hey, we have large tables with, I know, hundreds of millions of records, and how can we speed up the data there?
So then we need a direct conversion between, the format of the table to the Kafka topic, maybe.
Yeah, I mean, I think this parallelization, this will help. What also, of course, helps is if you just can narrow down the data, the amount of data you need to snapshot, right? So today you have the option. Let's say you have some records which are logical deleted. So you have this delete marker in your tables, and you only want to extract the active records which are not deleted. Then you can customize the snapshot select for the table. So you would just snapshot the non-deleted subset of the data. So that's also a possibility.
Yeah. Interesting. So this was the first feature, and we were already very excited about this. So what is the next one, if you have any? Interesting.
So let me see. I opened some Debezium blog posts. I mean, there's also lots of integration improvements, right? So we have, for instance, integration with open tracing. So that's also very cool. So it tells you where your time is spent if you have this sort of end-to-end messaging flow. So one of the things, I mean, maybe we have spoken about it before, is this Outbox pattern, right? Where you use Debezium to essentially exchange events from different microservices to each other.
Okay, so what is the Outbox pattern? So describe it as briefly as possible.
Exactly. So the default way of using Debezium is you capture your actual, let's say, business tables, right? So you have a table with purchase orders, you capture changes from it, and you send it to Kafka. Now, a concern which people sometimes have is if they take those change events and they expose them to external systems, it is kind of leaking the internal data model of this source application. And now this could be a problem, or it could not be a problem. Let's say I'm just taking the data to a cache, to a search index. I feel this sort of, exposure isn't a problem. But if I use the data to send it to another microservice, which really is an own bounded context and everything, then I would say, yes, maybe I don't want to expose my internal data model directly to such an external system. And this is where this Outbox pattern comes in, because maybe it reflects what people might have is, okay, I want to, do the updates to my database, but then I also would like to send an event to this other service to tell this external service about something. And the problem is you cannot do those two things, updating your database and sending something to Kafka in a safe way at the same time, because you don't have a global transaction. It means things will go wrong, right? You might end up with a state where you have committed the transaction in a database, but then this message sending to Kafka, that failed, or the other way around, and you might not even know about it. So that's really bad. And the Outbox pattern helps with that, because, well, in that case, you do the changes to your database, so you update your purchase order table and whatnot, and at the same time, you also insert a record into another table, this Outbox table. And this is really just a message which you would like to have sent to external systems. So there you could use a JSON-based message format or whatever you would like to use. It's a message contract which you consciously expose to the outside world. And then you use Debezium just to capture the changes from this Outbox table. And you send those Outbox events over to Kafka.
Okay.
So that's the Outbox pattern in a nutshell.
Okay. So it's just like adapter between your tables and one or facade to counter.
Yeah, it avoids this notion of dual writes, right? Because you only write to your database, and now, well, if your transaction gets rolled back, also this Outbox event would not be persisted, right? So we would also not send a message to Kafka via change state capture.
But then the Debezium would be set up just to listen exclusively on the Outbox tables, right?
Exactly right. And actually, by the way, I should mention it. So it is a table in most of the cases, but let's say in case of Postgres, what you also have is you have the ability to directly send messages to the transaction log. So there's a specific function forgot the name, something like PG logical emit message or something like that, which lets you send a message straight to the transaction log, so it won't show up in any table. And still, we could capture that using CDC, and then, it would give you a very efficient means of implementing that pattern. So there's actually, by the way, work happening for supporting that in the community, in Debezium at this point.
I actually know that Postgres supports a kind of messaging via the JDBC driver. I would have to check it whether it is also available via JDBC.
I believe you mean listen notify, right?
Yeah, I think so.
Yeah. Which, by the way, that's nice. You need to keep in mind only if you are not running, you won't receive any events. So that's the difference.
Yeah, just I just wondered whether this functionality you're describing here is available via JDBC driver, because then you could just directly send messages via JDBC to Kafka.
It is available. Yeah, I see what you mean. It is available in the sense it's a stored procedure or function, I don't know how they call it, which you just can invoke via JDBC.
Yeah, this is actually interesting, also for testing, right? So you could just very easily test, Kafka for tests.
Right. So, and let's say, and I'm all saying all that. So we have this Outbox pattern, and people use that a lot. By the way, we also have a Quarkus extension, which helps you with implementing this Outbox pattern. There you just need to emit a CDI event, which describes this event. And then this extension will take care of everything else, persisting it in the right table, maybe deleting it from the table, because this is also doable. We don't need to have the event in the table itself. We just want to capture it from the log. So you can insert and delete it right away. That's something you can do with this Quarkus extension. And now there's also support for distributed tracing for all of that. So you could go to Jaeger tracing, for instance, and then you could examine this entire end-to-end flow. You would see when has the message been, recorded in your application, when has it been persisted in the database, when has Debezium picked it up, and so on. So this gives you very nice end-to-end insight.
But it's actually crucial, because if you're even without Outbox patterns, so let's say what's interesting is when the data arrives into the database, and then let's say Debezium is interesting, but even more interesting is after Debezium, if you have other microservices just reading from. Actually, we shouldn't call them microservices, cause lots of confusion. Meanwhile, I talk about data processors or whatever. So it's just a process which sits on one Kafka topic and writes to another. It's nothing to do with microservices. So this process, does something with the data. Now the interesting part is how long does it take from the initial ingestion until you see something usable on the business side. And this with open tracing is a great idea. So you will just need to add the span ID, whatever it's called, to the message, so it will travel around.
Exactly right. So now what you can do is you can already insert the span ID, at least for the Outbox events. You can insert the span ID right in the source application itself into a separate column in that Outbox table. And I believe also otherwise you can configure it, so we can pick it up from a particular column, and then the span the trace will start even at the source application, right? If that's not the case, well, then we will take the commit timestamp. That will be the first span.
This would be enough, because which table you say. Okay, from the commit ID, I could, or whatever you have, I could just this is my initial start of the event, right? Yeah. Yeah,
exactly. And then, so this gives you this, I really like it, right? Going to Jaeger UI and being able to see, okay, that's the entire flow. You can see where time has been spent. And
this is the most requested actually use case. So in my project, because always the question, how long does it take until I see something, because Kafka is supposed to be real time, but no one believes that at the beginning. So, okay, how long does it take? And this is actually really nice, because you also see the lag. What could happen is that your database could happen. This is unlikely that the database is faster than your Kafka configuration, or you spend, your how to call it, the follower brokers cannot keep up, so you see some delay, and this could be also used for open tracing.
Yeah, definitely. So and there can be lag sometimes. So the other day we had somebody who reported they do an update which updates 50 million records in their table. So it's one innocent update statement, but then 50 million change events result out of that, right? So it will take some time to process those.
This is a nice stress test, by the way, right? Such an update for your infrastructure.
Absolutely, exactly.
So did we cover the killer use cases?
I believe so. Yeah, I think UI, incremental snapshotting, this entire notion of building out Debezium to a whole CDC platform. So yeah, I believe that's what has happened over the last few releases.
at the beginning, Debezium was for me, this is a question also to you from the architecture point of view, Debezium was for me more like a help to, to get rid of SQL databases. And or old monolith or whatever, so old infrastructure. Yeah. But meanwhile, what I use Debezium for is to, let's say, how to call it, empower. This was to empower developers just to to use the classic SQL which they actually like with Postgres.
Right.
And don't care all about the transactions and whatever. And on the other side, we can have the real-time analytics world. And they are perfectly decoupled. So meanwhile, I even see, and what you can do then, because also interesting observation, is that microservices, right? I don't know, they are somehow misunderstood, or at least what I see in projects, as developers are thinking they have to do them, and then they say, okay, I have a microservice and the database is completely isolated, and they have another microservice completely isolated, and they have like 50 microservices, 3 developers, and lots, of an entire and unproductive environment, right? Yeah. And what we did in some projects is we reversed that. We say, okay, small team, 1 database, no isolation, Postgres, and we built, larger microservices, but with really nice internal logical structure. So the modularization happens in packages, not on the microservice side. So you can be crazy productive. You reduce the amount of Maven modules and so forth. You have 1 Postgres database, but whether you have 1 Postgres or 10 doesn't matter. You have the same tables. So it means the data remains the same. And at the other side, we use Debezium, and we have the business events. Mm-hmm. And this is interesting. I never used the Outbox pattern because if I would use the Outbox pattern, the developers will have to do the work with the Outbox. You will have to convert, your table events, and this is no more as, how to call it, agile.
It's not fully transparent to the application side of things. That's true.
So the interesting part is what we do, the Outbox pattern is afterwards. So in my architecture, always, this was like the default Debezium. I had like the first service was the ingestion service, and or ingress, different names. Ingress, I think, is better. And what it does is Quarkus usually, it listens to the technical, it understands already the Debezium message, and creates a business message. And this involves, simple data conversions, data type conversions.
Right.
It skips the metadata. We don't need it anymore. I don't care then whether the event was created or updated. I just need to know my event. And maybe some simple joins sometimes, but this is what it is. And this is my Outbox, basically. And this worked perfectly because developers can do whatever they like. And we try to keep up on the other side,
right?
And we are decoupled.
Yeah, that makes lots of sense. I mean, there's different ways of going about it, right?
No, it's just with you, this discussion, because this is an interesting story. You told me about the Outbox, so I see the point. If you have Dennis will be like the database is a center of the universe. If I have Kafka, for me the database is just a nicer way to query the data. Because the Kafka or Kinesis is master of the data, no more the database. This is the idea. The Kafka is a single source of truth, and we are just misusing the database to move faster. Because if you PrestoDB, or I always forget the second name. What was Kino? Trino. Okay, exactly. This Trino or PrestoDB, it is not as the tooling is still not comparable with Postgres and SQL.
Yeah. Okay, I see. I mean, one of the things also to keep in mind is, so I totally see why you do it that way, and I'm very sympathetic. Was it one of the challenges which you may have? I'm curious actually, is so you will lack the information, or let's say you might lack the information about the transactional boundaries which happen in the database. So let's say, because you mentioned joining, right? So let's say what could happen is you do have a model where you have a purchase orders table, and then you have another table with the order lines, right? So it's like a 1-to-n kind of relationship. And now maybe you would like to produce what you call a business event, which describes the entire purchase order. So it would be a join between the two, and you would have the information about the order header, and then let's say 5 lines, right? And now if you do this joining after the fact, based on Kafka topics for the 2 tables, you will, by default at least, you would not be aware of any transactional boundaries in the source database. So what could happen is you run this join, and it will first pick up just, let's say, 3 out of those 5 order lines, and you will produce a join which contains just a subset of the entire order. And then you run it again, and Kafka Streams does it for you, right? So you don't really control it. And then you run it again shortly thereafter, and you will have the full join with the 5 order lines. And now, depending on your requirements, seeing this first intermediary join is something which you may or not may want to have, right?
With this joining happens with Kafka Streams joins,
right?
On my side. And if it happens, it depends which kind of join this is. So Kafka actually, I think, supports all kinds of joins. But you can specify, I always confuse the joins, whether the left or the right side triggers the update.
Yeah, sure. But you will have, at least from a Kafka Streams perspective, you don't have a way, but because you just don't know. I only would like to run this join once I have seen all those 5 insert events, which originate from that one transaction, right?
You mean you have individual inserts. So
yes, exactly.
Okay, but in my projects, we use Quarkus as microservices, or some Pyaras or Whitefish as well. But now the majority is Quarkus, and if you have the inserts, usually if you use JPA, the transaction boundary in my projects is on the boundary level.
Yeah, okay, sure. So they will all be inserted as one transaction, right? From a JDBC or database perspective. But then in Kafka Streams, you will just receive 5 change events. You don't know what is the transaction scope for them. At least by default, there is a way you can do it in Debezium, and we have the ability to expose another topic which tells you about the transaction boundaries. And what happens then is it will tell you on that topic, okay, so a transaction 1, 2, 3, it started, and then you will receive another event, transaction 1, 2, 3 committed, and then it will tell you, okay, in this transaction, there was 1 insert for order headers and 5 inserts for order lines. And now this is something which you could use in Kafka Streams to implement some sort of buffering. So you could implement it that way. So you await all those 6 events, and then only then you emit this join and you send it downstream.
Yeah. I think what happens in my case, I just thought about this because we use this mostly for analytics, and this was not huge, problem so far. But what will happen in this particular case is I will get multiple updates. So I think the joins in Kafka will fire multiple times. Exactly. So you will see one order with 1 line, with 2 and 3 and 4, but the order has always the same ID. And if you do, idempotent way, which you have, because if
it will be correct and complete in the end, right? It's just you will see those intermediary joins for a short period of time. And let's say you send that data to Elasticsearch and you do some search. So what could happen is you run the search and you will only get results for one of the order lines, right? Or for a subset of the order lines. And then if you run the search in Elasticsearch the next second again, then you would be able to query on the entire order. So this may or may not be a problem, right? So that's why I'm saying it.
What's also I said right now is the typical case, like, so such projects happen in several stages. So the first stage is we have a huge database, it's very important, don't touch it, do something, right? So, and then you install Debezium, you have the business events in the topics, and then you can do whatever you like. So if there is if the added value happens on the Kafka side, so behind Debezium, then we have more power. And then I wouldn't call it Outbox pattern, but what we could do, for instance, we could denormalize the database a little bit to make it more convenient. And and then it is without the Outbox, because Outbox is an additional step. This is the same transaction, but I have to do something. But if I adjust the database a little bit more, and this is what will happen in my project, what I will try to push for, because at the beginning of Java, I think my first Whitefly project, one of the larger Whitefly project, was 2002 or something like this. Yeah. And the administrator wanted to have fully normalized Oracle, which was terrible to work with back then. I think was Hibernate. That wasn't even JDBC or Hibernate. It was JPA was not on the horizon. And then we denormalized the database because it just didn't work. Right. And then it worked way better back then with performance and everything. And this I will see the same. No, first we get all the data out and then see, because also if I get the topic from you, like the transaction topic, it's still additional work involved, because then I would try to join, I don't know whether it's possible with the transaction topic, or do something about that, or wait until something happened. You have to, I will have to join with do with the best, right?
Yeah.
The first join would be, the order with the order lines. And the significant join would be, the commit topic with the order lines, because, and I will create from this the business event. This would be my approach then.
Right. Yes, and so definitely you can do that. And actually, that's also one of the things we are considering as part of the Debezium platform work. So we might provide you with some ready-made service or component for doing that, right? So we might give you a Kafka Streams-based microservice, which you configure, and you just tell it, okay, those are the topics which I would like to join, and it will do all this joining logic for you, and it will emit those events then to downstream topics. So that's something, if you find the time, we would like to do that as part of Debezium.
Yeah. What I'm wondering, what you could also do is that, the commits from the database.
Right.
You could actually buffer the events, right?
Well, we could do that, but and in some cases we even have to do that. The problem is this is a problem of unlimited growth, right? So if you can have large transactions. Sometimes people do it. I don't know why, but they do it. They run a transaction which goes for 10 hours.
Okay.
And this means we will have to buffer gigabytes of events, and this can be a problem, right? So that's why we try to avoid it as much as possible.
Yeah. Perfect. So, Gunnar, I think we will skip your other endeavors to the next podcast, because this was too interesting. But the title will be great, like, what's new with Debezium, in Debezium land.
Right.
And
definitely.
It was a really interesting discussion, because what I was curious about what I'm doing, whether it is a hack or a kind of best practice, but it can be either way. It depends on the project.
It sounds very reasonable what you do. Yeah. And I didn't know you are that an avid Debezium user, actually. So that's very cool to know.
Yeah, you know this because I found a bug and reported the bug and you fixed this. Right.
That was the one. But I didn't know you are using that much. That's very cool.
Yeah, it's an interesting project, and it started for me as a hack. And now it becomes more or less a best practice, how to use the best of words, because you can create your. Oh, the last observation.
Hold on. Can you tweet that? You need to tweet using Debezium as a best practice in modern microservices architecture or something.
Yeah, sure. After the discussion with Gunnar, this would be we'll do it right now. But in microservices, exactly. So this is my observation. The tables were always hidden behind the microservice. And you had to communicate a lot between microservices with really strange patterns involved, because you cannot just have joins. If the database is isolated, you have to use the APIs. So now the interesting part, in Kafka, is the other way around. So we have a view private topics. So this is the topics which are directly, how to call it, with the data provided from the table, with the one-to-one relation. And we have the business topics, which are more or less public. So the microservices can read and write, or read from the topics and write to other topics. And you get natural decoupling, because the microservices never know each other, because the topics are public. So with Debezium, I have the best of both worlds. So I have my monolith-like architecture on the left side, and the event-driven architecture on the right side with a high decoupling. What I always hated, the mix, like a microservice which are isolated but not fully, and I don't know, Kafka like a JMS. It was a hot mess. But now with Debezium, there's a clear boundary between the monolith request response world and event-driven, topic business event world.
Right. Definitely. Yeah, I see how you say that. It's interesting because so you seem to be a lot in this camp of I take my Debezium raw topics. I don't want to modify application logic at all. I would like to take the raw change event topics, and then I do some sort of downstream processing to produce higher level events, join them, and so on. And then there's another school of thought which, rather try to do all that as part of their application, using then this Outbox pattern and, sending specifically tailored messages already out of the application itself. So I just find it interesting to see how you can go about it in different ways.
Yeah, the reason is because if you're working in a project, the developers already have the database. And it's not like they have nothing to do. They are already under pressure. If I tell them create the Outbox pattern is not at the beginning to have Kafka, they will hate me twice. Say, okay, why? First, okay. But then I can come into a project and say, okay, do whatever you like. It's getting even easier. We can delete all the microservices, reintroduce monolith, and everything is going to be fine. And now it comes to Outbox. Before I write the data in the database tables to another table, why not just use Quarkus and write directly to Kafka? Because on the left side I have.
Oh, you mean only going to Kafka and never go to your database?
Yeah.
That's what it is.
Yeah.
Well, yeah, okay, but then you have lots of challenges around queries, right? Because you wouldn't have instant read your own writes, this kind of stuff. Or let's say, how do you implement the unique constraint with this kind of model?
This is absolutely true. But I mean, in such events where I will need a special signaling table or special communications, I can just use Kafka directly. This is what I wanted to tell Not for our. So we can always do this way. So I mean, the idea we can start without any change to use Debezium.
Right. That's certainly true.
This is a huge acceptance. If I would start with any change in the database, no one believes in Kafka first on Debezium. So what is this? And will it work?
Okay.
What you can do. We install this and see how it works. And on the right side, we create some windowing functions or whatever.
Right.
And then you see already the added value in management, and then you can change the database.
Right. Yeah, that's true. That's a very nice way of thinking. I saw that way of thinking mostly when it comes to legacy applications, which people don't want to touch at all, or maybe they don't even can touch them. I don't know. They don't have the source code any longer. But I see how it also makes sense in new development as you described.
Yeah. And the last thought about a legacy. Actually, the legacy application, so reasonable legacy, worked actually exceptionally well. So for me, legacy would be larger microservices, what we did with Java E. Now we do it with Quarkus. So code is the same, but let's run it on Quarkus. So I would get, 5 microservices or monolith, well-structured internally, a single database. It works perfect. If you have a small team of motivated developers and they know what they are doing, it's perfect.
Right.
So, But then if you introduce microservice here and you don't have 5, but 30 microservices, it is no more as nice as it was before. And the microservices you would consider as the modern way of thinking, which for me is a step backward, And with the Debezium, I can have both. This is the point. I wouldn't call it legacy. It's like to back to legacy and sell it as something. We just need a new world, a new word for this. Call it however you like. Right.
Yeah. Okay. I see. Yeah, that makes sense. That's awesome.
Thank you a lot.
Thank you. And let's talk about the other stuff then next time, I guess.
Yeah, absolutely. Okay, bye.
Bye-bye.